All right then, so welcome back to math, the best place to be. Math, 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 math. We love math. Okay, well, I love math, and you can learn to love it. So, anyway, today we're going to pump up the volume, pump up the volume, pump up the volume, and talk about volume jam. So, let's have a look at volume of a rectangular prism. Poof! So there it is. A rectangular prism is basically a rectangle that is three-dimensional. Think of your box of cereal, your box of books, your box of anything. If it's a box, a rectangular box, it's a rectangular prism. That's kind of simple. But do you know what else is simple? Finding the volume of the rectangular prism is also simple. We remember that the area of a rectangle is, whoa! Okay, so the area of a rectangle is the length times the width, or the base times the height. Same thing, just different words. It's like if you called Robert Bob. So, what about the volume of a rectangular prism? It's basically taking the area and then stacking it vertically, or taking an area and stacking it horizontally. We're taking an area and then adding a third dimension to it. But here it is. The formula for the volume of a rectangular prism is, boom! The volume of a rectangular prism is the length times the width times the height, or the base times the height times the depth. You could call it a bunch of other things. Basically, you take your three measurements, 1, 2, 3, and you multiply all three of them together. Poof! That gives you the volume. Let's try it. So let's say on this particular rectangular prism, let's go with the numbers 3, 4, 5. I don't know why. They're just good numbers. So if my measurements are 3, 4, and 5, if I just wanted to find the area of the footprint where it sits down at the bottom, I'd say 3 times 4 is 12. 3 times 4 is 12. No big deal, right? But now let's say I want to find the volume of the whole thing, not just the footprint area. The volume of the thing, I've got to multiply that third measurement. So 3 times 4 times 5, like this. There we go. 3 times 4 times 5 is 60, because that's 12 times 5, and 12 times 5 is 60. What else could we do, though? Well, how about another one? Whoa! I thought I was going to do another example. Wait, there it is. Okay, so with this one, we've got 2, 4, and 6. Those are nice numbers, right? Sure, why not? Well, let's see how this works out. Does it matter what order I do this in? Absolutely not. So here it is, written two different ways, 2 times 4 times 6, or 6 times 2 times 4. Our first one, 2 times 4 is 8, and 8 times 6 is 48. Bling! Now, what about 6 times 2 times 4? That's still the same thing, right? 6 times 2 is 12, and 12 times 4 is 48. So, there's proof that it doesn't matter what order it's in, it's still going to be the same thing. Take the three numbers, multiply them together. Boom, boom, boom. You've got your volume. Now, what about another example? Boom! There it is. So we've got another rectangular prism. It is 8 and 2 and 3, or 3 and 2 and 8, whatever order you want to do it in. We know we can do it in any order we want to. So let's just pick one and go. How about 8, 2, and 3? Bloop. 8 times 2 is 16. And 16 times 3 is, well, let's see, we could use the calculator because that's always an option in this class. Or how about this? If we multiply 6 times 3, that's 18. Carry the 1. 3 times 1 plus the 1 we carried, 48. Poof, there it is. I showed you the thinking long version way there. But yeah, 48, 48, 48. So here's a cool thing. 2 or more prisms can have the same volume even though the measurements are different. This one's going to be a slightly different shape than that one. They're both rectangular prisms, but like that one's tall and this one's kind of long. I mean, we could stand it up and it'd still, but 2 and 4 is not the same as 2 and 3. Volume is not determined by what the shape is. Volume is determined by the measurements of the shape. So, go out into the world and know that you can do all kinds of volume problems as long as you take the 3 measurements of your rectangular prism and multiply all 3 together. Remember also, you can get different shapes to have the same volume. Okay, and don't forget about volume. It's not a measure of how loud things are, at least not in math class. We're not worried about how loud your music or the bright colors on your shirt or whatever. We're not worried about that when we say volume in math class. In math class, we're talking about the amount of space inside something. I know that your heart is bigger than you yourself, and I love that you love that much. But volume in math class is the space inside a thing. So we measure it. We can measure it with like little cubes. How many little cubes could we stack inside our rectangular prism to get the volume? Well, the volume of this one, you'll notice it's 2 by 3 by, whoa, how many? Whoa, 2 by 3 by 8. I think I've heard those numbers somewhere before. But if we go through and stack up the cubes to see how many cubes it takes to fill the thing up, 2 by 3 by 8, we would have 8 layers of cubes that were 2 cubes wide and 3 cubes long. 6 cubes, 8 times 48. But when we're measuring this, what units do we put on this? Well, if we'd said inches, it's now inches cubed. If we said centimeters, it's now centimeters cubed. Maybe those were mile-long cubes, so it'd be miles cubed. That'd be a really big rectangular prism. I hope it's full of chocolate. So, remember, anytime you're stacking up the cubes to see how many will fit in the volume space inside of a rectangular prism, remember, the measurement is whatever unit you had cubed. The other thing about that is, you could say it's miles cubed by raising it to the 3rd power. You could write the word miles and the word cubed, or you could write cubic miles. Have fun! You know what's really odd? Every other number.